Okay, hey everyone. Thanks for coming to my talk about testing container images with Python and pytest. And first, as a warning, this might be more of a commercial because this is more about a testing plugin that I've wrote and that's been powering various test suites across openSUSE and SUSE. First to me, who am I? My name is Dan. I've been with SUSE for what feels like an eternity at this point. I contribute also in the Fedora community to openSUSE. And if you want to, for some reason, stalk me on social media, I occasionally post stuff there, maybe on Mastodon. Okay, but since we only have a few minutes and I wasted already one, so, testing container images with Python. Why don't you just use the shell? Because, just write a shell script, do podman run, because, that runs literally everywhere where you have your shell and your container runtime, and it's super fast and it's super portable, and everyone can understand them, right? Until something breaks and you don't understand them because anything, I'm not the smartest person, but every time I try to do string comparisons in Bash, something breaks. And then I ask an LLM or someone who's smarter than me, and then we spend half an hour, and then I think, Jesus, we should have just written this in Python. And that's because, and that's the reason why we wrote pytest container. Because I think shell scripts suck for anything more complex than moving files around, and especially if you want to test containers, things start to become ugly. So why should you use this thing or consider using it? Let's say you have container images that you want to test, because just pushing stuff into production and assuming it's going to work is maybe not the best plan. So what can this plugin do for you? It can automatically build containers, it will clean up after itself. The whole thing is written in Python. So it, in case you've ever heard about test infra, it leverages that for abstracting away all the ugly stuff like running commands, checking if files are there, checking if packages are installed. There's the part I'm kind of most proud about, and that's that essentially all of the operations support running in parallel, including things like exposing ports. So that's at least with Bash, that would be non-trivial. Which I already spoiled, the next feature, finding and binding free ports. FYI, if you try to do that, so Podman and Docker usually also support a way to expose ports themselves directly and find a free one, but they allow for plenty of data races, so I had to do it myself. If you're using Podman, you can also work with Podman's pods. The whole thing can also create volumes for you and clean them up for you. It supports for the use case of testing a software on multiple different base container images. You can do that as well, and you can use Docker, Podman, whichever you like. And maybe for the people who have the pleasure and privilege to work on SLE 15, it still works with Python 3.6. And will probably work until all eternity. That is at some point February 2038. Okay, so how does this look in practice? Just a little bit of Python code. Let's say you want to test the tumbleweed image, so you define yourself. I hope you can read that. Yeah, so you define yourself a container, you give it an URL, and then you plug that thing into a pytest test function, and in this case we just test, okay, is etc.os released there? Not the most useful test, but it's pretty much the simplest test you could do. Looks simple enough. You would run pytest, and it would pull down the image, launch the container, run your test, and then destroy everything afterwards. So what can you do? What can you use this for? First would be test your base images. If you're building an operating system, you might want to check that the containers are actually kind of sane and kind of work, and that's generally, supposedly that's a good idea. So you can also use it to test applications inside containers and not just do simple smoke tests. Or what I've also done for our various projects is, if you want to test that your software actually works on different operating systems, but you don't want to spin up VMs and futz with OpenQA, and the container is good enough, then you can use also this for that. Then you can also use pytest container. A little bit of a prep about what this heavily leverages pytest fixtures, which is essentially pytest's way of doing setup and teardown. And so a fixture is essentially something that gives you a resource. The best example is that's stolen from the pytest documentation is give me a connection to a SMTP server, for instance, or to a web server, or something that requires doing something before the test and destroying it after the test. And that's really where the heavy lifting of pytest container happens. So there's a few fixtures that are creatively called container something or pod something. I mean, it's container _ per test and so on. And they do the container launching and the container destruction. And the second part is you can do test parameterization. So that means you execute the same test function on multiple, you execute the same test functions for multiple values. In this simple example, it's just test and addition, but in the context of pytest container, you use that for multiple container images. So you could run the same test function on 1 container, 2 containers, or 50, which we used to do, or which we do in BCI. So let's go maybe through a few more interesting examples. What you can do is, as a typical use case, you want to build a new container for your test. So you give your test a base image. That can be something on a registry. It can be another already defined container image. You give it a container file. You put that in a creatively called derived container class, and then you execute your test. And if you now launch pytest, it will first pull the base image, then it will build this web server image, then it will launch your test, execute all the tests, and whether they failed or not doesn't matter. At the end, it will destroy everything, and but it will keep the container images around. So what happens is you can also define dependencies between container images. So let's say you have your base image, then you build on that a Nginx image. In this case, you just install Nginx. And then for some reason you want to have one with GDB and debug info. Maybe you've seen it crash very frequently. And if you plug that into pytest container, then you'll see that it will first pull the tumbleweed container, then it will pull the Nginx container, build it, then it will build the Nginx debug container, and then it will launch your tests and then destroy everything. And you can, don't do circular dependencies, that will break for sure. And that's not something that should work, so don't try that. But otherwise, you can have as deeply nested dependencies as you are motivated or as you have time to wait for them. The one, I would say, pretty useful feature is forwarding ports to the host. So this is relatively ugly to pull off in an automated test suite if you want to expose a port on the host. You can let the container runtime do that, and then Podman inspect and find out which port they're exposed to. And I don't want to see the JQ invocation that you would have to write to get those ports out. So don't use this, because all you have to do is define port forwarding. This is the container port, and pytest container will give me a port on the host where it's exposed to. It will pick one randomly, but one that's free. most of the time. There's a teeny tiny window for a data race that I haven't managed to solve yet. And it also only happens very rarely and in GitHub Actions. So yes, joy, exactly. Another thing, health checks. This is, I know this is not an OCI feature, it's a Docker feature, unfortunately, but it's very useful because what you also often run into with automated tests is you have an application. The application takes a bit of time to spin up, and when you test it manually, you do podman run my application, and then you try to test it, and it works, and then you write an automated test, and the automated test is much faster than you, the application is not yet up, and your test dies because it doesn't work. So add a health check that will test once your application is up, and pytest container will, by default, wait for your application, for your container image to be healthy, and once it's healthy, you can run your actual test. You can also check what the health status is, but by default it will wait for it to be healthy. You can be sure about that. If it's unhealthy, then the test will just die and not even execute. But you can turn that off if you don't want that for some reason. So use health checks, they're useful. Then pods. This unfortunately works only with podman because, well, Docker doesn't have that. In case you want to create pods, for instance, to have a shared network, then really the most useful feature of pods is to expose something to the network. It's on the host, it offers kind of the same interface as your for port forwarding as the containers itself, so it should look like itself. You just have a different fixture name, and then it the tests work the same way. So then in the case, so far I was showing really examples that shouldn't really mutate the container that you're launching. And there's an implicit trick that the plugin is doing most of the time. If you use the default fixtures, your containers will be shared between test runs. You shouldn't rely on that, but they will be, to a certain extent, be shared, because otherwise everything takes ages. But if you, for some reason, decide to do things like testing whether rm-rf/ works or whether deinstalling zipper works, then you should maybe run that using the container _per_test fixture, where you will get a fresh container for every single test. You can do that, but be aware that this gives you a performance hit due to the launching, destroying, etc. pp. In case you want to inspect your containers, there's also an abstraction for that. So you can, the pytest container will give you the container inspect, sometimes useful if you really care about your container labels or the CMD or the environment. Oh, I see I'm running pretty short on time, so you can also let it create volumes for you. This is really useful if you want to put something on the host and you need a temporary directory for that, so it can do that for you. Sorry, I'll just. Oh, okay, I have 1 minute left, I'm sorry. There's a roadmap. Don't look at the issues in detail, they haven't moved that much in a long time. But let's call it, the thing's mostly stable and doesn't change that much. So in case you want something that shouldn't break under you, it's used by various projects across SUSE and openSUSE. And in case you need something, maybe your project there. I think it's also used somewhere else, but people haven't told me. But I occasionally get bug reports from people running this on a Mac for reasons. Thanks for these lovely people. And thanks for your time. Sorry for taking too long. Give it a try.